Okay, 26. Let x and y be numbers such that negative y is less than x, which is less than y. So that could be something like 1 is less than 2 and greater than negative 2. Okay, so I kind of see what's going on here. Which of the following must be true? Okay, so to show it must be true, we have to show it's true in every case. Whereas if the opposite, if it's not true, we just need one counterexample. So it actually might be easier to prove them not true than true, which is kind of odd. But let's go ahead and see what we have. Roman numeral number 1. Absolute value of x is less than y. Well, I can express an absolute value as a complex inequality. It's simply I solve for the positive and negative case. So x is less than y, that's my positive case, and x is going to be the opposite of that, or greater than negative y. Well, guess what? That absolute value inequality is exactly the same thing as our given inequality in the problem. So for every case, they are the same. Therefore, 1 must be true. That's going to be part of our answer set. Well, I didn't really even need to do that work if I just scanned my answers first, because 1 is already in every answer choice. Oh, well, at least we showed it's true. Let's look at Roman numeral number 2. X is greater than 0. So, that's not obvious at first. What if x were not greater than 0? It would have to be, say, negative would be one example. Can I see a counterexample with a negative x? Say negative 3 is x. And that we're less than, well, let's go with our original numbers, 2, and greater than negative 2. Negative 3 is less than 2, but it is not greater than negative 2. Greater than is to the right on a number line. Negative 3 is to the left of negative 2 on a number line. Therefore, it is not greater, it's less. This part is wrong. Therefore, we have a counterexample, and Roman numeral 2 does not meet the condition must be true. So I can immediately eliminate B, for example, and I can eliminate D. It's now just a choice between A and C, and that really comes down to checking Roman numeral 3. So let's take a look. Y is greater than 0. Well, our original examples kind of indicated y is greater than 0 already. So in fact, if I took the other way around, I would say y would be, say, negative. That would be negative, say, 2 is less than 1 is greater than 2, assuming my negative y is plus 2 and my y is negative 2. That's kind of like our first case here, but the opposite value of y, a negative y. So is this true? Well, of course not. 1 is not less than negative 2. That's wrong there. But moreover, no matter what I put here in between, it doesn't really even matter what's there, because I can't be, whatever it is, call it x, cannot be greater than 2 on the one hand. So if we set up our number line, and that were 2, it can't be greater than 2, which is to the right. And, because remember, our compound inequalities here, it's an and condition. Both parts must be true. Both inequalities must hold at the same time. It can't be less than negative 2. What point could possibly be here and here at the same time? Not possible. In fact, this can never be true. The counterexample of y is negative can never be true. Therefore, there is no case where it won't be true. Well, with one exception, I didn't check y equals 0. So is that a counterexample case? Well, again, we have the same problem. 0 can't be greater than something and less than something at the same time. The only thing that possibly fit is 0, but even 0 doesn't work because then they'd be equal, not less than or greater than. So even that case doesn't work. There is no counterexample that could possibly work. So Roman numeral 3 must be true. It meets that condition. The correct answer for 26 is 1 and 3. One of the more interesting Roman numeral questions.